So we're missing Drawer, I guess, but he should be here soon.
Awesome. Yes. Yeah, this is the next thing I was kind of working on. So once we get done understanding the science notations or the definitions of it, because as I was going through it, I wonder how would it be, because you have to get the estimate of the weights, and then I forgot, what did we do last week, Isaac? You got to get the estimates of the weights.
Yeah,
and
so
we're that. That's what I was trying to figure out how that worked with equivocation. If you're going off the weight, therefore, how could you do that? And I kind of just got stuck there, and I was like, all right, group activity.
Yeah, so with the integer consensus, for the estimate values, we're computing this set that's called the median. And you have the definition there for the weighted median is, I guess, really what I'm referring to.
Mm-hmm.
Yeah. So sorry, what was the question?
Oh, just because when I was trying earlier this week, I was trying to figure out how would equivocation work. I kept like getting stuck on like, well, is it even possible with this? If you're taking the medium.
Oh yeah, so equivocation here is still exactly the same definition. So we still have messages that have three parts. The three parts to the message are an estimate; those are the values we're displaying. A sender, we display the name above, and the justification, which we're kind of graphically displaying with arrows between them or lines or whatever. And so in equivocation, in any of these consensus systems that we're looking at, so with binary we were talking about it, now with integer consensus, the equivocation is still exactly the same notion. So we're still just looking for messages that are not exactly the same, from the same sender, and not in each other's justifications. Or I guess neither one is in the other's justification is probably the more proper way to say it.
All right. Because I was just thinking about like last week where, for instance, let's just take Alex, Obama, and Tom. So you got like 9, 10. So we have 5. So it has to be greater than 5. So that leaves with either the 6 or the 9. And then from there, since Obama has the highest weight, it'll be 9. But how would it be if Obama just randomly wanted to equivocate? So even though he already has 9 stacked and he wanted to say -3, like how would that? That's one thing I was trying to like wrap my head around, but yeah.
And I have also a question related to this. Are the message that we are calculating, does it depends on the value of consensus? In this case, integer, or we are calculating median, but only about weights and not about the consensus value. I'm thinking, what if consensus value is some kind of string or just rolling term?
Yeah, this is specifically for integers consensus values.
But you're saying that this value is estimator value is dependent on the real value of consensus.
Oh, sorry, you broke up a little bit.
The estimator value is dependent on the value of consensus.
Yeah.
Yeah, so the estimator is going to take in not only the consensus values that the validators are proposing, like 6, -1, 4, and 9. It's also going to take in their weights, the 1, 4, 5, and 4, and then do a calculation that we can get into based on those. I wish Drawer was back. I watched the one that I missed last week, and he gave an awesome example or an awesome algorithm for how to calculate them, but I don't know if he did it. I don't think he did it on screen.
Yeah, and actually, yeah, and you pointed that out to me, and it was way better than the way I was explaining it.
So should we maybe we should try one. I don't know if Jeremy, if you want to just choose who's going to make the next block and draw in the justifications, and then we can talk about how to calculate their estimate.
That'd be great.
Let me slide this over a little bit. Minimize the screen. All right, so let's go with Obama.
Maybe you can copy the whole slide so you can have both.
All right, so we got, I'm gonna draw some lines. We do Tom. What else we say? Alex. Yeah, we could do.
He's got to do his own, or else he's equivocating.
Oh yeah, might be.
Cool. All right, that looks pretty good. That looks doable. So we've got this block here, and we know that Obama's creating another block, right? And the question now is, what is the estimate? Yeah, exactly. So you deleted that 9 because we don't know what goes there yet, right? And so now we're going to calculate that. And so here's the algorithm that Dror suggested that I really, really liked. Look at the 3 estimates that Obama has seen and write them out in order from smallest to largest. So that's 4, 6, 9 in this case. Yeah, nice. Okay. And then maybe maybe right above that, write the weights that correspond to each of those estimates. So the 4 was Alex's, he has weight of 5.
All right, so 4, okay, cool. So 5, got 1.
Yep, 6 belongs to Tom, and his weight is 1. 9 belongs to Obama, and his weight's 4. Okay, so all we've done is rewrite information that was already up in the picture there, but what we've changed is that we sorted it by estimate value. So now we're gonna look at each one of those estimates, the left column, the middle column, and the right column, and we're gonna see which one or ones of them satisfy the criteria for being a median. So let's start by looking at the estimate of 4. Okay.
So before we even start, I just want to say this method is so good. I already see what it's going to be.
Oh, nice. Yeah, cool. Cool. So yeah, so basically we're going to go through 4, 6, and 9, and we're going to say which one's our estimate. So let's look at 4, and we look at the weights of all of the estimates to the right of 4, right? So I'm looking at that first estimate there, and so we look to the right and we say, what's the total weight to the right? So Tomislav, what's the total weight to the right of that left column?
Total weight.
Yeah, total weight.
4. Oh, you mean the 10 for all validators, right?
All validators sum to 10. That's good. That's important, right? And half of 10 is 5. So in order to, so 5 is our halfway point, right? That's the threshold for whether something's a median. So Jeremy, can you do me a favor? We've got 2 rows there, right? Can you label the top row weights and the bottom row estimates?
All right. Let's see. I'm gonna extend this out.
Okay, cool. So the candidates for what Obama might write in his block are the estimates, right? He's either going to write 4, 6, or 9. There's no way he's going to write the 5, 1, 4. Those are weights, not estimates, okay? But to decide which one of these estimates is a median, we have to look at the weights. So we're going to look at them in order. So let's look at the 4, and then look at all of the weights that are to the right of the 4. So that's the weight of 1 and the weight of 4. Right? Can you highlight those for me, Jeremy? Bingo. Yeah, those are all the weights that are to the right of the 4. And so now the question is, when we sum those, 1 and 4 sum up to 5, is that less than or equal to half the weight?
Yeah.
Yeah, it is. Okay. And now let's look to the left of 4. Well, there's nothing over there, so that's 0. Is that less than or equal to half the weight?
No, right. 1. You mean 1 is smaller than 4? It's left.
We're looking. I wish I could point out the mouse pointer. So right now we're looking at the estimate of 4. That's the bottom left cell. Yep. Yep.
Oh, yeah.
And we're going to decide, is this estimate a median? And so there's 2 criteria for that thing to be a median. You can see it in Jeremy's 2-line equation over there. So the one condition is when we look right and we sum all of those weights, 1 plus 4 is 5, that's less than or equal to half. So we've met the first criteria. So now let's look at the second criteria. We look at all the weights to the left of 4. Well, there are none. 4 is all the way on the left. It's the extreme left. So when we sum all the weights to the left of 4, they sum to 0. And 0 is also less than or equal to 5. So we can conclude that 4 is a median in that case. Does that sound right?
Oh, yeah.
Yeah, cool. Okay, so we know that 4 is a median, but it need not be the only median. There might actually be more than one median, and it looks like in this case there is. So, okay, cool. So we're done analyzing the candidate of 4. Now let's analyze the next candidate, 6. All right, so we look at all the weights to the right of 6, and Jeremy, what are all the weights to the right of 6?
Just 9.
9's an estimate.
Oh wait, so that'd be 4.
Bingo. Yep. All the weights to the right of our 6 estimate sum up to 4. Is that less than or equal to half of the total weight?
Yes.
It is. Good. So we've met the first condition. 6 is looking promising. Let's check the second condition. Now we have to look at all the weights to the left of 6. So what do those add to?
Just 1. Well, the weights add up to 6.
So well, first of all, what are all the weights to the left of 6? So 6 is the middle column.
Oh, the estimate's just 4.
But what are the weights?
Oh, the weights is 1.
6
no, sorry.
5, but the weights left of 6 are
Only 5.
Wait,
only
just
5.
5.
Bingo. That's right. Yep. So remember, 6 already met the first criteria. We said that 4 is less than or equal to half the weight. So now, is 5 also less than or equal to half the weight?
No.
It's equal to. 5 is
Oh, yeah,
half.
it's equal to. It's all right.
Yeah. Yep. So that means that 6 is also a median. So 4 and 6 have both met both of our criteria. So that's not super common, but it happens as we demonstrated. Let's see if 9 is also a median. Tomislav, do you want to walk through that one?
So we are now looking for left from 9 estimate. So we have 6, which is not less than equal.
Bingo. So what can we conclude?
So 9 is not a median.
Bingo. That's right. We don't even have to check the next condition because the first one already failed. So the two medians here are 4 and 6. And so when Obama makes that block, he gets to choose whether he's going to have an estimate of 4 or 6. And then if, oh yeah, right. That's it.
Oh, yeah. So notice how different this is than just like the maximum weight of the estimates. Because in that case, we definitely would have gone with 4 because that had the most weight.
Yeah, right.
Yeah, that's interesting.
Yeah, so it's not yet totally clear to me why this is better or different. Isaac had a good hypothesis that it might come to consensus faster.
But I almost feel like this is a counterexample to that claim.
But you're saying that valid estimate is 4 or 6.
Yeah, correct.
Although 6 has only one weight of 1.
Correct.
Yeah.
Yeah,
it's unintuitive. It's a lot different than the estimator rule we played with before, right?
Yeah.
Before we played with a rule that I just made up because it seemed like a good generalization of the binary consensus. And it's funny because I think both of them did give us consensus, right? The one where we just added up the weights and then also this one, but they're just two different ways to get consensus, I guess.
Yeah.
So, by definition, will we technically put 4 where Obama was trying to get or getting for what I'm trying to say? So in here, should we actually insert 4 since it is? Wait, no. Oh shit! Now I kind of confused myself again.
Yeah. So the punchline, Jeremy, is there's more than one correct thing you could put there. You could either put the 4 or you could put the 6. But you can't put both. You got to.
Yeah, no. I'm just trying to look at it to.
Yeah.
All right.
But I'm confused because we are making consensus about integers. but we have consensus with some integers are like a favorite, and some ones are like you know what I mean. Nine is not like a.
Sorry.
Oh no! I'm not now. I'm thinking that. Yeah, if you look at the whole spectrum of integers, we are looking like the value that is in the middle, not the highest value of some like any value.
But
Yeah, but what is like we are choosing any integer.
But the thing is, like, well, who actually chooses the final integer, though? Because that kind of changes the course of everything. Well, it can, but
Yeah.
so it's like one thing if because we're not going off the weight, so it's just who then
we are going off the weights. We used the weights. That's why we wrote the 514 down at the bottom. We're just using a different, more complex calculation on the weights than before. We were just looking at which estimate had the most total weight, which did work. We're definitely not going back and saying like, hey, we were wrong before. That was also correct. But now we're just showing another estimator that will also lead to integer consensus.
So
I'm looking at this, which could be wrong, but is that we're looking to get the wisdom of the crowd, and just just a few samples, we can tend towards the median, but you really need the large participation to zero in on the number of bulls or whatever.
That's a great point, Jim. Oh yeah, because it struck me as trippy at first, like that we decided one of the valid things would be to write 6 here, and by the old rule, 6 is way out. 6 has the lowest weight by a lot, but it makes sense that that it's good by the new rule, because Tom is just this little fish who's wanting 6, but he's got Big Fish, Alex, and Obama on either side. He's like the sensible middle ground here. They can come together on a Tom value.
that's a great point. I think we should put 6.
Yeah, Jim, that comment opened up a big perspective for me. I'm glad you said that.
That's a really interesting point. I was gonna say before that that maybe it now just comes down to the particular implementation as to which value is selected out of the two. But I don't know, honestly.
Yeah, I could imagine if I'm coding this, whenever the estimator gives me options, I could just say like take the lowest option, or maybe what we could even code up would be like the first time you find a valid median, use that one and don't even bother checking the rest of them, or something like that.
Yeah. Well, but maybe the stuff we were talking about before with like taking the hash of like the particular protocol state and everything, like maybe that's a more fair way to choose the median.
Yeah, totally. But it's also just more computationally expensive because you have to check all your medians and then compute those hashes.
Sure. Right. Yeah. But again, I think we chalk it up to the particular implementation.
Yeah, totally agree. So what should we do next? We could do another one of those calculations, or we could move on, or whatever anyone's in the mood for.
Looks like Jeremy has some more slides.
Yeah, they're just I think 10 is like the last one. Group exercise, create a equivocation fault where more than the weight of the validators are equivocating. That was something I was still trying to wrap my head around as well, but we don't necessarily have to do that today unless you guys want to.
It's not. Yeah, I mean, it's not. You came up with it. It sounds like a good thing to try.
All right, let me just create a new slide.
My one question is, more than the weight of the validators are equivocating. Do you mean like a lot of the like more than a third, more than the 1/3 threshold or something?
I think that was, where did I see that? These days. I think, remember we saw that yesterday? Was it?
You mean that we have more
Oh, here it is.
equivocating
More
validators?
T weight of the validators equivocating.
Oh yeah, the T is important there. The T is a threshold, right? Some threshold that we get to choose.
Yeah.
So we can choose a threshold, and then I'm actually not really clear on how the threshold works. There's some, like, if as long as less than T of the validators are equivocating, then something like what was that all about?
Yeah, so the T is the equivocation weight. I mean, it's the Byzantine fault threshold, right? It's as long as we see no more than T Byzantine faults, which in this case are just equivocation faults, by weight, then we can guarantee that we'll come to consensus. Otherwise, it's not guaranteed.
But we get to choose T, right? So how does that work?
To some extent, I think really the choices are 1/3 or less, but I'm not certain on that.
But more than half. If you have more than half invalid, they can stop sending messages and freeze the consensus.
Yeah, so what I'm saying is I think our theoretical upper limit for the fault tolerance is 1/3. So T can be at most 1/3, but you may want to set it lower for, like, I don't know, some kind of computational reasons, but I'm not really sure what effects that would have.
So I thought there's no assumptions in CBC about the threshold. So
Yeah, but I think we have a lower and upper limit for a T, for number of Byzantine fault.
Yeah.
But should have been kind of specified if that was the case, no?
Well, I mean,
yeah, Jeremy, can you look at equation 105? I think that answers this question. It's way down at the bottom.
Oh, equation 105.
Yeah. Keep going. It's in Appendix A. It's way down there.
Here we go.
T is a real number, and it's between 0 and the total weight of all validators. Which does seem totally trippy to me, because I don't know how you could pump it up to 99% or whatever. Or if you can, why doesn't everybody?
Yeah, but I think that comes down to the slashing mechanism. So if we have slashing, I think we can pump it up to 99.99 whatever %. But without that mechanism, then you still have that threshold of 1/3.
Or even it doesn't have to be slashing, but even just ignoring, like we talked about.
Yeah, right.
Okay.
Yeah, exactly.
Once I see that someone equivocates, then I just ignore them.
Yeah.
Yeah. Okay, that makes sense. Yeah.
Yeah, and so I guess because the way that this is set up is you're just ignoring those dishonest validators, then really you can tolerate any amount of Byzantine faults.
Right. If everybody is dishonest but me, then I can still come to consensus with myself.
Well, yeah, you're already there, basically.
Right.
But can you have a consensus that will hold for any messages in the future? Because I was thinking that you must have at least 50% to be sure.
Well, so yeah, I think that's when you can't ignore the individuals that are faulty, or at least when you can't know who's faulty and who's not.
I think at some point I thought I remembered reading a sentence that was like, you can have you can have safety among any honest subset of validators as long as more than half of the weight of that subset is sees each other agreeing and doesn't see each other disagreeing.
Yeah. Well, yeah, you're right, and that's for the clique safety, and then if you have the clique safety, that guarantees your consensus safety, but we might be able to get it with less.
Wait, no. Clique safety doesn't guarantee consensus safety unless the clique is big enough.
Right. If the clique has more than half the weight, then we have.
Oh, that's what it was. Yeah. Right.
Yeah, but I think the case is that you don't necessarily need the clique safety. That's just a sufficient condition.
Oh. Yeah.
But
What's clique safety?
that's something that we should talk about at some point. Maybe we can do that next time, actually.
That seems like a good topic for next time.
Yeah.
I'm interested in that.
Yeah. Okay. Cool.
I haven't even seen if it's in this paper. I guess it probably is, but I haven't read it all.
Oh yeah. Good
It
point.
is. I think they renamed it to decision something, click decision or something. Decision safety maybe, or some estimate. I don't remember.
Yeah. So maybe this is a good time to talk about this, since it looks like it's about 5 after the hour. So should we at some point, and I know Josh's stance on this, but I kind of want to ask everybody else. Should we at some point like kind of do almost a line by line read of this paper and like go through all the mathematical symbols and talk about what all of the notation means, and do like a more rigorous coverage of this paper, maybe like after we build up the ideas a little bit more?
Yeah, I'm down.
Yeah, I mean,
I like to be a math wizard myself, so that'd be kind of cool.
Yeah, so okay, cool. Yeah, I asked because I don't mind preparing some stuff and presenting that information, but I'm wondering if maybe we should just talk about like all of the ideas kind of separately, and then try to do like the full dive into the paper with the proofs and everything.
I applaud you guys doing that. I've gradually lost my interest in rigorous mathematics over the years. I'm more interested in things like classification problems, like set membership consensus.
Interesting. Do they do that in this paper?
I don't think so.
Okay.
So, Jim,
that's almost
an interesting problem. Can you give us an example? Can you give us a problem statement? Like so there's 6 of us on this call, right? And maybe we're talking about the set of cool things, and I'm suggesting that like My Little Pony is cool, and you guys are like, no way, and we've got to come to consensus over it.
Yeah, what it is a quantum bit of information.
Okay.
Okay, we have either this X is in this category or X is not, and that is a general thing. It could be is this a project that we want to do? It could be well, it's a very general case. Classification is well, it's category theory basically related, which I'm not all that. I accept what they say about it.
Yeah, that sounds like pretty rigorous mathematics right there.
I think more in terms of all the theorems of the predicate calculus or whatever.
Yeah. Okay. Yeah. Okay. Cool. So in our list of topics for the future, we've got clique safety, we've got set membership consensus, and then more of a linear reading through of the paper at some point.
Sounds good to me.
Yeah, great.
Oh yeah.
All right. Well, Jeremy, this is your week. Are you ready to call it?
I'm ready to call victory, yo.
Nice.
Cool.
Good. Thank you for preparing those slides, man. Those were great.
Yeah, I'd like to thank Isaac as well for helping me out yesterday, like understanding it, because I was like going through some of the math.
Oh man, thank you for agreeing to host and doing everything that comes with it, man.
Oh, that reminds me though. Who's going to host next week?
Ooh, Tom, I think you might be next.
Oh, me? Okay.
Yeah, it makes
Okay,
sense.
sure.
Cool.
It makes sense, I think, to use my room unless there's a better alternative.
I always like using your room, Jim. Definitely. I feel like we have the highest chance of someone wandering in and being like, "Ooh, this is cool," in your room.
And
Yeah.
and you all should have the host code in case I'm not there. You can claim host.
And then we can record and everything.
Mhm.
Yeah, cool. Is that to what degree is that secret information though, right? It's at least not public information.
Well,
Or is it? Or it doesn't really matter.
we trust everybody until they
Until they equivocate.
Until proven dishonest.
Cool.
But-
Okay. Well, I guess maybe Tomislav, if you're hosting next week, you can get that host key from Jim, and that's our good path forward.
Yeah, sure. I will.
All right, gang.
Looking
Okay.
forward to it. And I'll try to get the video up later today. Jim, let's try to sync up so I can get your copy of the video or second half.
I could just put it up as part 2 on DiviDow.
Oh, fair enough.
Or you were going to put these in a different place?
Oh, no. We could do part 1 and part 2. That works. Yours can just be part 2 and I'll put up part 1.
Right. You have access to the channel, right?
Yep.
Awesome.
Sweet. Thanks a lot, Jim.
Yeah, and hey, I'll add some descriptions and put them all. I created that playlist, the Casper Collab playlist on your DiviDow channel, and I'll add descriptions to all the videos at some point in time. I can't give a timeline or anything.
Awesome.
Yeah.
Awesome.
Thanks so much for that.
Yeah, no problem. All right, guys. Thank you.
All right, take care.
Yep.
So,
See you later.
Bye.